Hi students, welcome back. In the last class we discussed about electric power and heating effects of electric current. Okay, today we are going to discuss about what are the practical applications of heating effects of current. Okay, the devices which make use of this heating effects of current. Okay, the device which make use of this heating effects of currents are first one, electric kettle, okay, electric heater, electric iron box, etc. Okay, in these devices, the part which make use of these heating effects of current is coil. Okay, the part which make use of heating effects of current is the coil. Coil which when current passed through the coil, it becomes heated up and the heating effects is produced. Okay. Then what's the reason for this much amount of heat energy produced in that coil? Okay, for this we use the material like nichrome. For this we use the material like nichrome. Nichrome is an alloy which is having higher resistivity than that of metals. Okay, it's an alloy which is having higher resistivity than that of metal. That is the first point. This type of material, nichrome, it's an alloy. Alloys are having high resistivity than that of metals. Okay, nichrome which is made up of three elements, that is nickel, chromium and iron. Okay, nichrome which is made up of three elements, that is nickel, chromium and iron. Okay, the first property of nichrome is it is having high resistance or high resistivity. And the second point is when electricity passed through this nichrome wire, it becomes heated up. Okay, and it remains in its heated state or red hot condition. It remains in its red hot condition for a long time. Okay, but it does not undergo any oxidation. Oxidation is a type of metal corrosion. That means the metal does not undergo any destruction. Okay, the second point is when current passed through nichrome wire, it becomes red hot and remains in its red hot condition for long time, but it does not undergo any oxidation or metal destruction. Okay, that is the second point. It remains in its red hot condition for long time. Without undergoing any destruction, without undergoing any metal corrosion. Okay. Then the third point is, we already studied that when current passed through this nichrome wire, it becomes red hot, but does not undergo any melting. Okay, this wire does not undergo any melting, and it have the capacity to withstand at high temperature. Okay, that is, it is having high melting point. The third point is the nichrome wire is having high melting point. Okay, the third point is it is having high melting point. That is, it does not undergo melting when the temperature increases. Okay, these are the 3 points. Due to these property, nichrome wire is used for making electric kettle, electric heater, electric iron box, etc. Okay, the second point is the device which make use of heating effects of current is electric bulb. Okay, In the case of electric bulb, a filament is there. Okay, that filament is made up of tungsten. Okay, that filament is made up of tungsten. What about the property of this tungsten wire? When electric current passed through this tungsten wire, it becomes red hot and remains in its red hot condition for long time and emits light energy. Okay, this is the first property of the tungsten wire. It becomes red hot for long time, but it does not undergo any melting. Okay, then first point regarding the tungsten wire is it remains in its red hot condition for long time. Second point is it does not undergo any melting. That means it is also having high melting point. Okay, it remains red hot condition. Condition for long time. And the second point, it is having high melting point. Okay, and this tungsten can withstand up to 3380 degrees Celsius. Okay, that is it is having high melting point. Okay, and the third point is the gas which is filled inside this electric bulb is inert gas. Okay, due to that inert gas, it does not undergo any chemical reaction between tungsten and that gas. Okay, so it have long life. Okay, the tungsten element which does not undergo any corrosion or does not undergo any destruction with the reaction with the nitrogen or the inert gas which is filled in this electric bulb. So the electric bulb is long lasting. That is the third point. It is long lasting. Okay, and the third one is electric fuse wire. Fuse wire which is the device or electric fuse or safety fuse which also make use of this heating effects of electric current. Okay, and the material which is used to make fuse wire is certain metals or alloys. Okay, alloy which is made up of tin and lead. Alloy which is made up of tin and lead, and certain metals like copper, aluminium, etc. also used for making fuse wire. Okay, what about the peculiarity of these elements? Okay, these elements are having low melting point. Okay, these materials are having low melting point. Okay, then when excess current passed through the fuse wire, this fuse wire, it becomes heated up. When current increases, heating energy is also increases according to Joule's law. Okay, heat energy produced around this conductor also increases. Due to that heat energy, the metal wire undergo melting. Okay, when it melted, the connection becomes breakdown. Then current will not pass into the home appliances. Okay, that's the functioning of fuse wire or safety fuse. Okay, these are the first one: electric heater, electric kettle, electric iron box, etc. And the coil of that devices which made up of nichrome wire. It's an alloy. That material is having high resistivity and it is also having high melting point. And again, one more peculiarity is that is it remains in its red hot condition for long time but does not undergo any oxidation. Okay. The second type of device is electric bulb. In electric bulb, the filament, okay, which is made up of tungsten, it can withstand up to 3380 degrees Celsius. That is, it is having high melting point. And it's also, when electric current passed through this tungsten wire, it becomes red hot and emits light. Okay, it emits light energy. That's the second point. And the third point is the gas which is filled inside this electric bulb is inert gas. So tungsten material does not undergo any chemical reactions with the gas. So this device having long life. Okay. And the third one is fuse wire. Fuse wire which is made up of tin and lead. The alloy of tin and lead and copper or aluminium. And these materials are having low melting point. Due to that low melting point, when electric current passes through this wire, it becomes heated up and begins to melt. Okay, so now we can do certain problems related to this heating effects of current. Okay. Our first question, 100 joule of heat energy is produced in each second in a 4 ohm resistor. Find the potential difference across the resistor. Okay, here 100 joule of heat energy is given. 100 joule. Heat energy given is 100 joule. Produced in a conductor in each second. In each second means time t is equal to 1 second. T is equal to 1 second. In a 4 ohm resistor, that is resistance is also given. Resistance R is equal to 4 ohm. Find the potential difference across the resistor. We want to find out potential difference V is equal to question mark. Okay, what about the relation connecting H, T, R and V? Okay. We know that the equation for the heat energy H is equal to V square divided by R into T. Okay, this is the relation connecting these terms. Okay, H, V, T and R. Okay, now we can substitute its value. H is equal to 100 equal to, we want to find out V, therefore V square into time t is equal to 1 second divided by, what about resistance? Resistance R is equal to 4 ohm. On rearranging this equation, V square is equal to 400 into 4. 100 into 4, that is equal to 400. Then V is equal to, okay, on taking square root, it becomes equal to 10 into 2, it's equal to 20. 20 volt is the potential difference that is found across the resistor. Okay, it's a very simple question. If you know the equation for the heat energy, H is equal to V square divided by R into T. Our second question is, compute the heat generated while transferring 96,000 charge in 1 hour through a potential difference of 50 volt. Okay. Our question is, compute the heat energy developed or heat generated. Heat generated means heat energy generated. We want to find out that. Okay. While transferring 96,000 charge. Here charge is given. Charge Q is equal to 96,000. Okay. Coulomb of charge is given. 96,000 coulomb of charge is given. In 1 hour, the time interval is also given. Time t is equal to 1 hour. 1 hour is equal to 60 into 60 seconds. Okay, 1 hour is equal to 60 into 60 seconds. Through a potential difference of 50 volt. Okay, potential difference is also given. Potential difference is equal to 50 volt. Okay, these are the data given. We want to find out heat energy. Here charge is given, time given and voltage V is also given. Okay. Now which equation we want to use to find out the heat energy? Okay. From here, what about Q by T? Charge divided by time is equal to current. Okay. Current is known, voltage is known, time is also given. Then which equation we can use to find out the heat energy? heat energy H is equal to V into I into T, VIT. Okay, what about V? V is given, V is equal to 50 volt. Okay, then what about I? I is equal to Q divided by T into T. Okay, then T get cancelled. Therefore, 50 into, what about Q? 96,000. Okay, on solving this, we can solve this as 96 into 5. What about 96 into 5? 9 into 6 into 5 is equal to 35. Remainder 3. 9 into 5. 45. 45 plus 3 is equal to 48. Okay. Therefore, it becomes equal to 485. What about the zeros? 1, 2, 3, 4. Okay. Then what about the heat energy developed here? Heat energy developed is equal to 985000. Okay. What about the unit of this? All these terms are in SI unit, so its unit is joule. Okay. I think this topic is clear for you. If you like this video, please subscribe and enable the bell button. Thank you.